Okay, so in problem 47, what are you going to do to start with? All right, how do you get at the x in problem 47? I'm going to erase this and try to put it up here. Now we're going to go step by step because it's not hard, although I grant you this looks tough. All right, so 47 says 0.8 to the 2x equals 0.007. Okay, the first thing that I've got to be able to do is I have to get at the exponent. How do I do that? I want log base b of b. Right? This is my base. So I want to take the log of the 0.8 base, 0.8 to the 2x power. That's going to give me the 2x. But if I do log base 8 here, I have to do log of 0.8 of this number over here. All right, now this gives me 2x equals. Now, are these two bases different? Okay, what does property number 4 tell you to do? Take the log of what? 0.007 and divide it by the log of 0.8. That will give me 2x. How do I get 1x? Divide this by 2, and if I do that, I get 2 log of 0.8. That's what you put in the calculator. Make sure that this whole thing is in parentheses. Log point, whoop. Wake up. All right. Log of 0.007 divided by parentheses 2 times. And if you don't put that in parentheses, what will happen is you'll divide it by 2 and then multiply it by the log of 0.8, which you don't want to do. So you could also have done it this way. Log 0.007 divided by 2 divided by log of 0.8. You could have made both of these divided bys in your calculator depending on which you're more comfortable with. Okay? 11.118056. So yes. Okay? Alright, so hard or easy? It's a thing. It's a thing, right? It's work, right? But is it so now again, so the handout that I gave you with those 4 properties on it, those are the things that you're going to be using in the next couple chapters. Okay? Alright, now. Oh. Can't read the time. 48. Half hour. Okay. All right, turn to page 283. 283. See the blue box on 283? That's property number 4. Okay, we've been working with it for 2 weeks because it's important. Okay? And that's the 4th property, isn't it? Right. Okay, so if you turn to 285, and the first odd problem says the log in base 5 of this weird number. Okay, how do I find out what that is with my calculator? This is property number 4. So what do I put in the calculator? I put log in base 10 of the weird number divided by what? Log base 5, log of 5. So log of the weird number divided by log of 5 is the same as that problem in the book. Because we have we have log base 10 in our calculator. We don't have log base 5, so we can't throw it in. All right, so go to problem number 7. How do you solve that? All right, log of 58 divided by log, was it 23 or 3?
0.3.
Oh, log of 0.3.
Yeah.
Log of 0.3. Not hard, right? Give me those all day long. Right, that's just calculator work. All right. Now, so when you get to 13, what do you notice in problem 13? You got log 39, log 49 of 49. Those two cancel out, and so the simplified answer is x. The simplified answer is x. When you have log base 49 of 49, that value is 1. What exponent of the base 49 do you have in order to get 49? 49 to the first power, right? So the log 49 of 49 is the number 1. Does that make sense?
Yeah.
Okay, and so what's left?
The 8.
Is that an 8? I thought it was an x. All right. So the answer is 8.
Right.
Okay? Now, in 15, you're going to have to do a little work. But you see log 24, 24? That's going to be the exponent. So it'll be 3 times negative 2 over 3, which is negative doso. Now, 17 is a new form. 3 to the log 3 is just the same as log base 3 of 3. All right, so the 3 as a base and the log base 3 cancel out, and you're left with 7. Okay. And then the same thing with 19. 10 log 10 cancels out, right? And so you're left with just a 9. All right, that will help you with those. Okay. Now, inverse functions. Inverse functions. All right, flip over to 293. Now, okay, I am not happy with how he does his inverse functions. Okay, I learned inverse functions in a slightly different way. So I'm going to make a problem. Okay, now, to find, this is what f of x equals. Now, to find the inverse, which is written like this, all right, the power of negative 1 is the flip, right? So, this is representing the inverse of x. Okay, here's how I learned this. The first thing you do is switch the x and the y. So I change this to x equals 2, y minus 3 plus 4, and then I solve for y, and I'll have the inverse function. Okay? Now, what the book says to do is to get the x by itself and then switch the x and the y, which to me doesn't make sense and didn't make sense when I was taught it. Okay, this makes more sense. All right, now, so what do I do to get at that y? What's the first thing I have to do? I got to move this. So that will make this x minus 4. Okay, now this is gone. What's the next thing I have to do? I got to get rid of the 2. No, not add. This is multiply, right? So therefore, I'm going to divide by 2. All right? That takes care of this. Now, how do I get rid of the 3? Okay. See? then because, all right, I subtracted the 4, divided by the 2, and then I had to add the 3, and now the only thing left on that side is y. So this is the inverse of that. Okay? Now, that is supposed to be Algebra 1. Supposed to be. All right. Okay, so, everybody got that copy? All right, let's do another one. Okay. Okay, what I want to know is what's the inverse of that? So, this is y, right? This says equals y. So I'm going to change the x and the y and say 2y minus 3 divided by 5 equals x. That's the first step. You missed it. I'm going to spell it again. And you missed it because you were actually right. Okay, so what do I do first to get to the y? Multiply by 5. So if I do this, I get rid of that. What's the second step? Add the 3, right? I add 3 here to make a 0, and so I do plus 3. What's the third step? Divide by 2. So that's the inverse. The inverse is 5x plus 3 divided by 2. All right? Now, that, in my opinion, that's an easier concept to be able to do. It says the exact same thing that Forrester's doing, but I think from the step point, that shows me what I'm trying to do. Okay? All right, so the rest of those will be relatively simple. Okay? All right, so now we're at 613. Now, I think I got this written down, so let me get to it. Yes, okay. All right, now. Trying to figure out how to do this. Okay, let me start right there. All right, so if I were working with an exponential function, an exponential function has some base raised to some power, and then times some other number here. Right? This could be 1, which in case there wouldn't be, it'd just be b to the x power, right? But what this is going to equal is that it's going to equal n times, and then I'm going to have b times b all the way down until I run out of x number of b's. Right? You got that? All right, so when I put it in the calculator, I'm just going to do whatever this number is and raise it to that power because the calculator does the adding faster. Okay? But that's the math. All right, now, here's my question. This is important. What would happen if I asked you for the n plus 2 power? What would be the difference between this and this? It would have 2 more b's in it, wouldn't it? Because the original would have been this, and then I would have had times b for the 1, 2 extra b's.
Yeah.
Okay? Everybody see that?
Yeah.
Now, so what happens when I divide? All right? Do the ends cancel?
Yeah.
All of these will cancel, and I'll be left with the 2 b's. Okay? So, if I knew the value of this, and I knew the value of this, and I divide them, whatever this number divided by this number is, it equals b squared. So how can I find b? Take the square root of it. That's what I learned driving here this morning.
That's amazing.
Please, you weren't gonna tell us.
Huh? I had to. Because it makes perfect sense.
Yeah.
But I didn't find it when I read it.
Gotcha.
I didn't see it when I read it. Okay? So here's what happens. This is it. So if I have this second number, right, the one that's higher, increasing. If I take the increasing one, divide it by whatever this is, right, what happens when I divide is I end up with two b's, right, because this was a 2, right, and that means whatever that number is, I take the square root of it, and I have what b is, which is my original number. Okay, so now let's turn to page 299. Let me see if I've got them here, if they're on a different page. No, that's what I learned. Okay, so now I'm going to kill that. Can't see it. There it is. Okay. Okay. Now this example says that f of 3, when the x was 3, I had 100. When the x is 5, which is 3 plus 2, I have 80. Okay? So that makes this. That makes the x of 3 plus 2 equals 80. And then the x of 3 equals 100. Well, I'm going to divide them. And when I do that, I find that this divides out to x to the second power equals 0.8. All right, now, the first thing that they do is that every increase of 2 will be a multiplier of 0.8. So we were at this, in your calculator, multiply 100 times 0.8. Increase of 2 will make a multiplier of 0.8. Now do that again. Take 80 and multiply it by 0.8, and that'll be another increase of 2. 64. Do it again. Alright, so we can get, because this original information was a difference of 2, I can go up by multiplying the value by 0.8. Now, if I want to go down, I have to divide by 0.8. So let's go back. Take 100, divide it by 0.8. 125. Okay, so if I want to go one more down, I'm going to have to go 2 less than this, which would be -1, and then take 125 and divide it by 0.8.
156.25.
156.25. Now, all of those things could be plotted and you would have the graph of that exponential function. That's the first thing that chapter 13 is telling you about.
Gotcha.
Okay?
Got it.
All right, so if you look at problem 1, first of all, look for the values of x. In problem 1, you're going from 2 to what? 2 to 5, right? The values of f of 2 to f of 5 is an increase of 3. So the next one that you're going to be able to do will have to be 5 plus 3, f of 8. And then 3 to that, 8 plus 3, f of 11. Now, what is the value? The value is 54 divided by 36, which in the calculator is 1.5. But I used it as 3 over 2. So you can take one. You can take this and multiply it by 1.5. You end up with that. Multiply by 1.5. You end up with those numbers. Now, to go less, you have to divide by 1.5. Okay, now look at problem 2. What's the interval? X is going from what?
3 to 7.
3 to 7. How much is that? 4. That's a change of 4. That means I can go from 7 to plus 4, 11 plus 4, 15. That's where they come from. If I'm at 3 and I subtract 4, negative 1, subtract 4, negative 5. That's where those numbers came from. Does that make sense? Now that should make that page much easier to understand. And remember, if you've got access to this video, right? Okay, this may be one when you actually start working it that you want to bring this video up and actually go over this again. Okay, so because this makes sense. Now, when I read the text, I didn't get that. All right, but that's what he was trying to get me to do. Okay, does that make sense? Now, all right, so let's look in number 9, just real quick. These are the x and y, right? So they would have been the variable points. So let me ask you this. What's the difference? What's happening to the x's? Going up by 3. And when they go up by 3, the multiplier is going to be 48 divided by 12. The second one divided by the first one. What is 48 divided by 12? 4. Okay? So, the value of b will be the 4th root of 4. That's the value of b. Now, all right, let's go back to this one. This is going up by 2, right? So, the square root of 0.8 will be the value of b. What about this one? Going up by 4. So the 4th root of 6 over 5 will be the value of b. See? That in the b to the x power. Now, we still have a number n we got to find. But if you remember, when we started this, the n simplified out, right? And all I had left was however many of these. Right? The example I showed you was by 2. Right? So again, let's say, how do I find that? How would you, in your calculator, if you needed to find the 4th root of 6 over 5, how would you do that? Okay? What you should do is go parentheses, 6 divided by 5, raised to, now the 4th root is the 1 divided by 4 power. Okay?